Walk onto any modern hangar floor, and you will quickly discover that the idea of the aircraft mechanic as a jack of all trades is a complete myth. Because commercial aviation technology is incredibly advanced, licensed engineering is strictly divided into highly specialized disciplines. Technicians dedicate their careers to specific fields like airframe, power plant, or avionics. Basic certification only gets you in the door. To legally execute and certify safety-critical tasks on specific models, like an Airbus A350 or Boeing 787, organizations require technicians to undergo rigorous type courses. These courses provide exact in-depth knowledge of proprietary systems. Without this specific training, a technician attempting to interact with a modern airframe goes from being a crucial safeguard to a major safety hazard. Aircraft maintenance is intensely physical work, yet the most critical phase of any procedure happens before you even pick up a tool. Blindly executing a task without proactive planning is a guaranteed way to invite errors. The engineering team must pause to verify they have the required calibrated equipment, up-to-date documentation, adequate lighting, and crucially, the personal skill level required to safely perform the job. A job card acts as a vital cognitive job aid, an external hard drive engineered to prevent human memory failure by detailing every discrete step in the correct sequence. To maintain airworthiness and break the aero chain before it starts, engineers must abide by one non-negotiable rule. Do exactly what is written in the approved data and accurately write down exactly what you have done. Regardless of the trade, physical execution relies on your musculoskeletal system. The maximum force you can safely apply is strictly bounded by muscle strength and mechanical advantage. When technicians contort themselves into confined spaces to reach components, they destroy that advantage. Pushing past those limits leads directly to debilitating musculoskeletal injuries. This simulation screen demonstrates how aircraft are engineered for ease of maintainability. Manufacturers utilize computerized ergonomic tools based on human performance data to ensure routine tasks actually fall within the physical capabilities of an average technician. If a physical task feels impossible, stop. You must locate the approved hoists and specialized tools rather than invent an unsafe workaround, because ignoring your physical limits inevitably compromises the integrity of the aircraft. While physical limits are obvious, psychological traps are entirely invisible. When you perform repetitive tasks multiple times a week, the required skills become stored in your long-term memory as automatic motor programs. This automatism breeds severe complacency. A technician makes the highly dangerous assumption that they know a procedure perfectly, completely bypassing the maintenance manual. During monotonous visual inspections, this introduces expectation bias. If you inspect an engine blade hundreds of times and never find damage, your brain is conditioned to expect a clean result. You will look directly at a hairline fracture and cognitively fail to notice it. On April 28, 1988, an Aloha Airlines Boeing 737 suffered a catastrophic explosive decompression mid-flight. The sheer stress ripped approximately 18 feet of a cabin's skin and structure entirely away from the aircraft. Post-accident analysis revealed that over 240 distinct cracks existed in the fuselage lap joints before the aircraft ever left the ground. Two inspectors, with decades of combined experience, completely missed the damage due to the extreme monotony of their routine visual checks. Their extensive expertise offered no protection. The repetition actually increased their vulnerability to expectation bias, proving that the human mind is often its own greatest liability on the hangar floor. This psychological trap can blind an entire organization. When a Royal Air Force Nimrod crashed, analysts realized decades of repetitive reviews had created organizational automatism. They assumed the aging legacy system was safe simply because it hadn't failed yet. Today, complacency is a growing threat as aircraft transition into highly integrated electronic systems, where thousands of sensors and computers must operate in perfect unison. Tracing aileron control evolution, early aviation utilized a direct physical cable from the control stick to the flap. If broken, technicians could visually trace it. Modern fly-by-wire systems sever this connection entirely. Electrical signals are actively modified by a flight control computer. Troubleshooting these massive data interactions is highly abstract. An engineer attempting to diagnose a fly-by-wire fault using outdated mechanical intuition without rigorously following the job cards guarantees a catastrophic error. The ultimate danger of a complex system is its ability to completely mask a single human mistake from the technician and the flight crew. During ground tests of this cabin pressurization system, technicians switched the mode selector to manual. Rushing the closeout and leaving it there creates a dormant, latent error. Because crews rely on automation, they may not recognize the degraded system until the aircraft fails to pressurize. In August 2005, this exact sequence, a single missed step on a job card, caused the fatal depressurization of Helios Airways Flight 522, leading to crew hypoxia and the loss of everyone on board. In highly automated environments, a minor procedural deviation does not immediately trigger loud alarms. It sits silently embedded in the system as a latent error until it initiates a disaster. Back on the hangar floor, surviving this error chain requires deliberate mental discipline. Technicians must actively train themselves to expect a fault every single time they begin an inspection. You must consciously manage cognitive fatigue. Taking short, structured breaks between specific structural zones resets your visual acuity and prevents your brain from wandering. The only true defense against the fatal traps of complacency, expectation bias, and complex system automation is treating every single routine task exactly as if it were the very first time you are performing it.